Alright, section 3.1, more stuff with linear equations. We start with a word problem that says a belt costs $30 less than a pair of jeans. And then it says the ratio of the cost of the jeans to the cost of a shirt is 2 to 1. If the total cost of the 3 items is $75, find the cost of the jeans. So we have a pair of jeans, a belt, and a shirt, and they're all going to add up. Well, okay. Basically, probably like starting here. The jeans, whatever the price of the jeans is, plus whatever the cost of the belt is, plus whatever the cost of the shirt is, would all equal $75. Okay, but we can't necessarily be satisfied, or we can't actually ultimately do anything if we say, let's call the jeans price J, let's call the belt price B, and let's use the variable S for the price of the shirt. Then you would have like J plus B plus S equals 75. You can't solve an equation when all you have is just one equation and there's 3 different variables. You can't really solve for anything. You haven't really gotten anywhere. So we have to be a little more clever than that. And here's what you pretty much try to do. You can call the jeans J, like whatever the cost of the jeans is, we'll call J, and then we try to use that same variable J, like we try to describe what the belt costs, but in terms of J, okay? And we're also going to do the same for the shirt. We're going to describe how much the shirt costs, but we're going to do it in terms of comparing it to the cost of the jeans. And so we're going to use only the J variable to describe all 3 of these unknowns. So as far as the jeans go, that's just going to be J. Okay, but the belt, how can we describe what the belt costs as related to what the jeans cost? So we can just use the letter J again. And it says up here, a belt costs $30 less than a pair of jeans. So what that basically means is whatever J is, the belt would be J, whatever the jeans is, minus 30. And that's how we can pretty much describe the belt. And how about the shirt? That's a little bit trickier, I suppose, in my opinion anyway. As far as the shirt, excuse me, the ratio of the cost of the jeans to the cost of the jeans, the cost of a shirt, is 2 to 1. It's a 2 to 1 ratio. What that basically means is that the jeans cost twice as much as a shirt. You know what I mean? 2 to 1 ratio, that's what that basically means. So whatever the price of the jeans is, because the jeans costs more, the jeans is twice as much. So in order to describe what the shirt is, we would have to call it J divided by 2. And if you took whatever the jeans cost and divided it by 2, it would equal the price of the shirt. And so that's how you can describe the shirt. So now what we have is a more workable equation. We've updated our equation from this to this, and now this equation only contains the variable J, and so here's the point. We can solve it now. Like, we can actually solve for J. We can get J by itself. I'm not exactly sure I remember what I put behind this box, or like how many steps I did at once or whatever, but I will say this. As far as the parentheses go, you normally have to clear parentheses first. These parentheses aren't really parentheses you need cleared. Same with these parentheses, not the type to need cleared. Here, you would technically have to clear these parentheses, but what would you distribute? A plus sign, a positive 1, technically, and that wouldn't change anything. We can essentially just drop all the parentheses, including these parentheses right here with the j minus 30. So let's see what's behind the box. And, oh, okay. I see what I was doing here. So the minus 30, just comes on down. There's no other like terms that we would look to combine with the minus 30. But as far as what the j's combine to equal, this would be 1j, this is going to be another 1j, and then this is essentially half j. Okay? So it's like this would be 1j, this would be, well, let me, you know what, let me, it'd be like this, 1j plus 1j plus, and then what this essentially is half j. And so those are three like terms that we can combine, and this is essentially going to be 1 plus 1 plus half is 2.5. 2.5. The fraction for that would be 5 halves. But I don't want to super complicate this problem. So I'm just going to write it as 2.5j when I add all those like terms together. The minus 30 comes on down and then equals 75. And now, I'm one step closer to having j all by itself and solve for j. So we can, this should seem pretty expected. We add 30 to both sides in order to, again, get j one step closer to being by itself. And now we grab a calculator just to be sure here, because next we're going to divide both sides by 2.5. So 105 divided by 2.5 gets me 42. So j equals 42, which is $42. So let's make sure that we've done everything the directions want us to do. What they ultimately want is find the cost of the jeans, which was j. So we got it. So the final answer here is just the one answer of $42. If they would have asked for all three items, we could easily do that now to finish it off. And maybe we should anyway, just to double check that we have a correct answer, that it makes sense for the jeans to be $42. So if the jeans were $42, that means the belt is $30 less than that. So that would mean $12 for the belt. Let's write that in there as well. $42 for the jeans. If the belt is $30 less, that means it's $12. And if the shirt, I'll just repeat this sentence here. The ratio of the cost of the jeans to the cost of a shirt is 2 to 1. That means that the jeans is twice as much as the shirt. So that means the shirt would be $21, which is like half. Saying the jeans is twice as much as the shirt is the same as saying the shirt is half what the jeans would cost. So that would make the shirt $21. Now do all three of these numbers add up to 75? 42 plus 12 is 54. 54 plus 21 is 75. Yep. Well, that was quite a word problem. That was quite a word problem. So hopefully you understand that. That's how it's done. Other than guessing and checking, and now we're going to do a few more examples here. And what do we want to do first? right? Don't we always like to clear the bubbles first with the distributive property? Now remember, peoples, the 2x is not being multiplied to that group of terms. Nope. So we do not distribute the 2x. What we're distributing here is just a minus sign, or technically a minus 1. Okay? And so with distributing that minus sign or minus 1, minus 1 or negative 1 times 2 is negative 2, and then negative 1 times positive x is negative x. So then we get to here. And the next priority is, combining like terms that are already on the same side as each other. In this case, we got the 2x and the minus x. And so we just combine those. They're already on the same side. So 2x minus x is x. Minus 2 is still there, equals negative 12. And now what we're going to do is get that x all by itself, simply by killing off that minus 2 and getting that away from there by adding 2 to both sides. And so your final answer, with x being isolated now, is x equals negative 10. So more of the same. That's actually nothing new from what we've already done from previous lessons. This one is very similar. I guess, based on what I just said, maybe we've never quite put so much emphasis on distributing what is pretty much just a minus sign, a subtraction sign, or again, what's technically a negative 1 that's directly in front of the bubble. So maybe I'll just, make it a point to emphasize that. All we're really distributing here is like a minus sign, a negative sign, or a negative 1. We're just subtracting everything in that group of terms. Not the 3x. That does not say 3x times the bubble. It's 3x minus that bubble. And if anything is going to get distributed, it's the minus sign or the minus 1. And when we distribute that negative sign, clearing the bubbles, the 2x becomes a negative 2x, and the positive 1 becomes a negative 1. And now we finish this off the way we've been doing for the past, handful of lessons. So 3x minus 2x is x. Minus 1 comes down, everything else comes down. And now we look to move things away from whatever side they're on. I want this negative 1 out of there. And so we add 1 to both sides in our effort to leave x alone. And we end up with x equals negative 5, because negative 6 plus 1 is negative 5. Another example where we need to just distribute first. So we need to distribute that 0.6, and we also need to distribute this 0.2 and clear both bubbles. So 0.6 times 1 is 0.6. 0.6 times negative x is negative 0.6x. And then likewise in the other distributing situation. All right, so 0.2 times x is just 0.2x, and then 0.2 times minus 5 is just minus 1. Okay? And now we look to what? What do we need to do next? We need to combine any terms that are alike and they're already on the same side as each other. So the 0.6 minus 1 we can combine, and then these two x terms we can also combine. So we get negative 0.4 when we combine this guy and this guy. Remember, it's 0.6 minus 1, and then this is negative 0.6x plus 0.4x, so it's negative 0.4x. The signs in front matter. Now that we've taken care of that situation, we now can try to get the x all by itself by adding 0.4 to both sides, which leaves a negative 0.4x on the left side, and so we're going to be dividing by negative 0.4. And when I recommend a calculator to help you do this, and you get negative 26. For this problem, just throwing different miscellaneous stuff at you, like here, mixed numbers, right? Now, I would say at least here, 28 and a fourth, 1/2 x, 91 and a fourth. The decimal for 1/2 is just 0.5. The decimal for 1/4 is 0.25. Those are pretty nice, commonly known, fraction to decimal equivalencies, right? So what I would recommend is that a quick rewrite, like before you do anything huge, before you do anything earth-shattering or before any like real moves in order to solve this, maybe you rewrite it so that you're not involving, mixed numbers and fractions. If we could just change it to a super clean decimal here, super clean decimal, why not? And now I think that's easier to handle and work with moving forward. And so now we would say, oh, that x and this 0.5x, those are like terms. So what's x, which is essentially just 1x, plus 0.5x, wouldn't that be 1.5x? And next we just do the same kind of stuff we've been doing. Now we get x by itself by getting rid of that, and then dividing both sides by 1.5, and the right side ends up being 42 when x is all by itself. Last problem, another word problem. Here we go. Josh saves $5.85 in dimes and quarters over a week. He has 6 more dimes than quarters. Find the number of dimes and quarters he saves. Right? So, what's unknown here is the number of dimes and the number of quarters that, totals $5.85 and holds true with the whole there's 6 more dimes than there are quarters. And so if your first natural instinct is to start like guessing and checking, it's not the worst idea in the world, but we're trying to work on different skills here than just guessing and checking. So we're going to name a couple of variables, right? And I don't know how in-depth I need to get here, but I'll say this, right? With the jeans, belt, and shirt problem, we had 3 different variables, which were like way too many variables, and we were able to rewrite all of them in terms of just one of the letters, the J. So here again, we have 2 variables, which 2 variables, that's too many, you know what I mean? But if you can write, I guess here's what I'm getting at. If you can actually come up with 2 equations that involve the 2 variables, then you can stick with having like 2 variables, like kind of throughout the... It's a little more complicated than that, just a little bit, but you'll see what I mean in a second. But I guess to kind of say something else about that, the original problem from example, oops, like this initial example here, if we could have written like 3 different equations, which we kind of did, then we can make it work. And we did ultimately make it work. I don't want to like reinvent how we did this problem, but technically this was like a second equation that we could have wrote separately. That B equals J minus 30. Okay? And this right here on its own could have been like a third separate equation, as in S equals J over 2. And then we just like used all three of those equations, all three of these facts, the fact that they all add up to 75, the fact that a belt was 30 less than jeans, the fact that a shirt was like half of what jeans were. We put all three of those together to help us figure out three unknowns. Okay, and we're actually going to do something similar with we're not stopping just yet. We're going to do something similar with the unknown number of dimes and unknown number of quarters. Okay, so the one fact that we know is that they add up to $5.85. How can you take like whatever the number of dimes is, and then whatever the number of quarters is, and how would they mathematically end up being $5.85? Wouldn't you have to like take the number of quarters, whatever it is, and multiply it by 0.25? Right? And then wouldn't you have to take like the number of dimes, whatever it was, and multiply it by 0.10? So basically, the 0.25 times Q, that's the total amount of money that we have in quarters. And this 0.10 times D, that's the total amount of money we have in dimes, and it's going to add up to $5.85. And again, kind of like what I've been sort of laying out here as an overall theme, this equation on its own doesn't get us anywhere. One equation that has two different variables, we can't get anywhere with it. So we need this other fact that there are 6 more dimes than there are quarters, so that we can like write this other equation, really, right? And say like, well, that means that the number of dimes is going to be equivalent with the number of quarters plus 6. Like whatever the number of quarters is, the number of dimes is going to be that number plus 6. Right? And so we have this other second equation. And so if we can rewrite the letter D, like the number of dimes, in terms of what the quarters were, we can then take this Q plus 6 and replace that D with it. Like that. Okay, and that's essentially what we did with the jeans, the shirt, and the belt problem. Right? And we were able to write an equation that only had one variable at a time. Because we were able to kind of rewrite the number of dimes as the number of quarters plus or minus or times whatever, okay? And now we take this equation, since now it only has Q, we can now solve this for Q. We start by distributing and getting here, okay? And it looks like I ran out of room, and so I'll just finish it here live, just like the other one. What would we do next? Wouldn't we combine the like terms, right? 0.10Q and 0.25Q, those are like terms. So that makes, find some room over here, 0.35Q, just in case here. I feel like I'm going to need all the room I can get, so move that over. So that becomes 0.35Q. Then there's that plus 0.60, and it's going to equal, oh my gosh, 85. This is embarrassing. And now we're going to look to what? Subtract 0.60 or 0.6 from both sides. And what's that going to be? That's going to be 0.35 Q equals, because those cancel, and then that's going to be $5.25, I do believe. And then our final step is to divide both sides by 0.35, and calculator time, 5.25 divided by 0.35. So the number of quarters, Q, is 15. So Q equals 15. Is that the final answer? Is that all that's needed? Because again, Q, what we just found, Q is the number of quarters, obviously. Find the number of dimes and quarters. So, well, easy enough now, okay? If the quarters was 15, then wasn't the dimes 6 more than that? So the number of dimes would have been 21. Okay? Because that adds up, or that, so there were 6 more dimes than quarters, and, you know, if we do 21 times 0.10 plus 0.25 times 15, we get $5.85. So guessing and checking could have got you this correct final answer. I don't know how long it would have taken, probably not that long, but again, the point is we're not trying to improve our guessing and checking skills. Not saying guessing and checking isn't a good, workable, useful method. But we're trying to work on other skills, like working with variables and writing equations and understanding all those concepts. And now we can stop.